Hey guys, Al here. Finally getting around to doing the comparison between the two conventional soil tests and the Haney soil test. I will be honest with you, it took me significant amount of time to really fully understand everything within the Haney soil test, or at least good enough that I felt confident to make this video. So what I'm going to do here is we're going to compare things that are similar on the tests, that being pH, organic matter. Those are things that are very similar and reflected on all three tests, and then kind of go through the Haney test and what some of the things mean and how the information is presented, because there are slight differences in how the Haney test is done. And that's when I'll go down to the second tab here and basically show you just a screenshot of what the Haney test looks like. But to start, let's start with the pH. So the Haney test results you see here in row 2, pH. So the Haney test results actually came back at 7.9. So relatively, excuse me, relatively close in comparison to the other two labs. So it doesn't appear that the pH has a huge amount of variability, at least in this small sample size. The organic matter percentage in the Haney soil test came back at 4.6. That is a little bit troubling to me because, as you see in lab 1, came back at 3.7. Now again, I have another video showing how I pulled these samples, but it was really controlled using a soil probe. 3 different holes were taken right next to each other. Those samples were then broken up and split equally into each baggie. They were then stored in the same conditions, and I repeated the sampling procedure 10 times throughout the, the sample area, which happened to be my garden in this particular case. So to have that large of a variance in organic matter was a little bit troubling to me, or I shouldn't say troubling, but I guess it tells me that organic matter percentages based in soil test analysis really should only be used as a guideline, because if you look over here at the USDA information, for every percent of organic matter, that's going to help to increase your water holding capacity by 20,000 gallons per acre, which is really important, right? That's water infiltration, specifically at large, if you're calculating irrigation costs or something like that for large scale farming, that could be a significant number there. Also, if you're looking at your soil organic matter in the top 6 inches of a medium textured soil, so that's, again, I think I mentioned this in another video, but relative to your CEC. But what that means is, so you can expect for every percentage of organic matter, 10 to 20 pounds of nitrogen being released. So on the high end, the Haney soil test, came back at 4.6. So you're roughly at, what is it, like 92 pounds of nitrogen that will be mineralized or plant available per acre at a 4.6 percentage of organic matter. And then you compare that to lab 1, 3.7. I don't know what that comes out to be. I did the math earlier. I think it was like in the 70, 72 or something like that. So it came back to almost 20 pounds per acre difference just in nitrogen, just based on the organic matter results. So again, and then you can go to the phosphorus, etc. You also, one thing I will note is look at phosphorus. Only 1 to 2 pounds per acre made available with an increase of 1% of organic matter. That just goes to show you how bound up and immobile phosphorus is in the soil profile. But nonetheless, we'll keep moving here, but I just want to highlight that. I know I've had a lot of frustrations over the years wondering why is my organic matter going up and then going down and then going up and then going down, and then again, over a 5 to 10 year period, I can see a trend, which is more so important to me than maybe a year-to-year change, and I'm going to continue to stick to that, at least from what I've learned and observed so far in my own soil analysis. So Other than that, there isn't a whole lot of similarities between these two, or between these three, I guess I should say. So I'm going to jump over here, and we might have to jump back and forth. I guess the line recommendations are also 0 for the Haney test. So this is what you receive when you receive a Haney soil analysis. So again, this is what we just went over. Your pH is 7.9, your organic matter. So now you have all this other information, and we have to just determine, well, what the heck does it mean? So let's start going through some of these. And I did email, just to be clear, I used a lot of help on this. I did email back and forth with the lab that did the testing, and their agronomist and PhD who handles the Haney Soil Test, and I had them answer a lot of my questions just to make sure that I could present this in the best information possible. Again, I'm not an expert, so if I do make a mistake or misspeak, my apologies, but I'm going to try to do my best to make this clear and concise as to what these different things mean relative to my soil test, but also what they would mean or relative to my soil, I suppose, what this soil test is telling me. And if you wanted to then take this test and do it yourself, hopefully this would be useful. So obviously organic matter, that's organic matter. Soil respiration, so this is some people call it the CO2 burst test, Solvita test. This is a shot in time, right? So it's a 24-hour test, and basically what this is measuring is the microbial activity in the soil. So anything over 100 ppm is very high. That shows a high microbial activity in the soil. So 244 is not to toot my own, it's fantastic. It shows very good microbial activity in the soil. They're doing what they're supposed to do. I had asked the lab, I said, man, that seems very high. Their response is the CO2 release is a measure of the microbial activity that has increased with the cultural practices that you are using. So I had shared with them that I'm using cover crops, no synthetic fertilizers, no-till methodologies, etc. Because the cover crops are providing a diversity of living roots in soil and extremely conducive to building soil microbial communities. So their thought process, obviously I took this sample in, I think it was end of May, or yeah, probably end of May. So, timing as far as breakdown of residues and things like that was probably also good. That is going to be variable throughout the year, as are much of the things within the soil test. But that's a really good indicator. Now that would be a good baseline starting point for me. So if I tested the soil at roughly the same time of year every year, I wouldn't want to see this number go way down, and I wouldn't want to see it go way well, I guess if it went way up, that would be a good thing. But you'd want to be use this as somewhat of an indicator. Especially one of the things they recommend is using the similar dates to test, and hopefully you'll get similar weather conditions because, of course, microbial, the soil's living, right? So if you have a cold spell or something like that, microbial life will slow down. If your thatch isn't as thick and you have very hot temperatures, microbial life will slow down, especially if the soil is getting overheated, etc. So there is variability there, but I was very happy to see that number. So water extraction. So one of the things that Haney, Dr. Rick Haney, believes in is not using harsh solvents, which that is what is used and I can't remember if it's sulfuric acid or not, so I apologize about that. But in a standard soil test, they use solvents to extract the nutrients, and there's various solvents used actually, I believe, to determine which nutrients are available or which nutrients are in the soil. However, as Dr. Rick Haney says in some of his presentations, it doesn't rain acids, right? So it rains, well, I guess acid rain, but that shouldn't be occurring, right? So what it does rain is water. And when it rains water, what happens in the soil, right? So when you receive rain, there are natural releases of nutrients, specifically nitrogen. And this is what that is reporting, right? So when they expose the soil to water, they take a reading in parts per million. Just if anybody's interested, parts per million to pounds is just multiplied by 2. So if you ever want to see what is that in pounds per acre, so like for example, organic nitrogen pounds per acre with the water extraction method is about 30. So that is how that's used. In order to extract the other nutrients, macro and micro, so your inorganic nitrate and ammonium. So these are naturally in the soil. They are still inorganic nitrogens, but just want to highlight that nitrate and ammonium are in the soil. Your phosphorus, your inorganic phosphorus, your organic phosphorus, etc. H3A extract. So again, Dr. Rick Haney talks about this. That is I think he calls it a mild solvent. But what it is it is the closest things that they can replicate in the lab to a root exudate. So root exudates or organic acids that come out of the roots, sometimes called liquid carbon, sometimes called amino acids. Just for the talking purposes, we're going to stick with organic acids. And when they expose the soil to this H3A, which is let's just call it a broad spectrum root exudate, this is what they are able to extract. So it's not as harsh of a solvent as some of the other things that are used. It's much more based on a biological principle to mimic a root exudate. And this is what is coming out of, what is showing that is in the soil. It is repeated up to here as well. So when you go to the lab's website that shows, they basically have a range. My soil is testing very, very well. So basically on everything, iron, zinc, magnesium, copper, I am way above. I'm in the optimal range or the high range for all of these. Again, I wrote to the lab. I will read you their response. They said these are high but not excessive. This is strictly a result of the cultural practices which equate to a regenerative system that raises the soil microbiology. Both the diversity and the quantity that release these nutrients from the non-soluble mineral soil particles. So again, the lab is confirming that through the use of cover crops, I am increasing the plant availability of a lot of nutrients. Excuse me. One that is neat to me is iron. To see the iron becoming available, iron is one that is often oxidized in the soil, why you get that red tint, and a lot of times, according to like John Kemp, you can get a really strong plant response from foliar chelated iron spray because iron is so often bound up in the soil, and a lot of times if you're not using cover crops and you haven't increased your iron availability through root exudates, right, and through cover crops, that in the first couple of years using a foliar spray of chelated iron can really give you a response that you might be looking for, make the plants look really green. Actually, I think he equates it to what a lot of folks would think you would get out of like a urea application, kind of that burst of green and growth. And it sometimes can be as simple as a liquefied iron or solubilized chelated iron, making it plants available right away because iron bounds up so quickly. Obviously, we know that about phosphorus as well, seeing that the phosphorus availability is strong. Copper and a lot of these other trace elements are again above what was showing as good, so kind of in the great category and having ample availability. So I was very, very happy to see that. So let's get up to your calculations. Calculations here, so they have a couple different unique mentions. So microbial active carbon percentage. So I had to ask about this because I wasn't 100% sure. So they do have a chart, and they show that basically anything over, gosh, I think it's like 30 or 50 or something is good. So mine's way up there. Again, This is just an indication that there's a lot of microbial food within the soil because of the decaying cover crops, because of the high activity of microbes in the soil. That's a really good sign that the soil is very, basically it's very microbial active, right? So I asked the lab about that, and this is their direct response. This is an indication that the utilization of the microbial food within the soil is utilized extremely efficiently. So just it's a good indicator. Uh, let's keep going. So organic C to N. So this is not to be confused with your um, carbon and nitrogen of say a cover crop balance or anything like that. This is specifically to your uh, water extractable nitrogen, your water extractable carbon. Just to note that. So I asked the lab about this because mine's 8-to-1, which seems very good based on their charts that they provide. Yeah, perfect is about 10-to-1 or 12-to-1. As you get to that 10 to 12, your efficiency of nitrogen mineralization, which basically means nitrogen availability to the plant, is greater. If you get higher than that, your nitrogen, like if let's say 20-to-1 or something like that, they would most likely recommend more legumes to help to lower that carbon and nitrogen, and vice versa. So I'm at 8.7, which is a little bit, I mean, it's in the good range. I would say that I probably need to add a little bit more carbon to increase just that balance there to the system, and increase the amount of food to make sure that not nitrogen isn't being consumed either. So basically their response to this is, I says, it seems good, but do I need more seed to balance out better, correct? And their response was more water soluble carbon can only come from more root exudates, which we know that, or organic material breaking down, so residue, which will ultimately stabilize naturally as all of the feedstock for this to happen is in place. The lower water soluble carbon is most likely as a result of the massive microbial population that needs to get fed, and this will happen from organic material breakdown. And the lower the C to N ratio, the faster this process will happen, and ties up with your high MAC, microbial activity, active carbon, excuse me. So basically what that's saying is because this soil came back as a high microbial active soil, which is very good, you got to feed those microbes. You don't want those microbes to start to starve and start to eat your organic matter, and die off. So how do you do that? Well, you need carbon sources. So I do have interseeded rows of in my garden that I continuously mow, so I'm continually adding additional carbon sources. I do make compost that I will most likely throw there, which will have some carbon in it. And I also will continue to add grass clippings and things like that. I'm trying to not have to go out there and source anything at this point, other than some like foliar sprays, fish hydrolysate or something like that. But if need be, I will go get some straw, just to continue to make sure that there's enough food for those microbes. But I think throughout this growing season I will be fine, and then I can increase my rye, wheat, and other higher carbon cover crop elements going into the fall and winter after my last tomato harvest is taken off. We will continue down here. So, okay, so that's really, soil health calculation. Basically, although they do give you a range on that, it's very much indicative of your environment. So one of the things that I heard Dr. Haney talk about is if you have a hedgerow, go over and take a plug out of that hedgerow and use that as your baseline starting point for your soil health calculation because it's relatively undisturbed, or a tree line or something like that. Another thing is use this as a baseline for year over year. Again, assuming that you're taking it at the same time. you know, because there is going to be some variability there, and you can look up as to how that's calculated. I'm not going to get into that because I don't want to get too much longer in the tooth here, and we're kind of getting into the meat here of the overview. So the last thing I want to touch on, so nutrient quantity available for the next crop. So this is really where it gets interesting, right? To me, this is kind of the meat and potatoes of the entire Haney Soil Test. So what this tells you is this is your organic plus your inorganic plus the release of nutrients, excuse me, that are needing to be or that are expected to be plant available for your next crop. So this is assuming that we took this right before I had planted my tomato crop or pepper crop, etc. This is what is available per acre. So why is this important? Well, this Haney Soil Test recommended that they kind of use a standard recommendation, right? So they give you, the calculation would have been like 60 pounds of nitrogen and 50 pounds of phosphorus. That does not take into account what is actually available. So basically what this is telling me is I have enough in my soil, I don't need to add anything. Now there is a little bit of, I'm going to say kind of judgment here, right? Because we have to understand that is all of this immediately available? You know, what is the efficiency of the particular plants taking it up, etc. But I will mention that, you know, if we go back just quickly, it is significant. I mean, look at these tests. So you had, between these two, one recommended 160 pounds per acre of nitrogen. The other one recommended about 70. This is telling me I have 64 pounds available. Same with phosphorus. So one test recommended 45, one recommended 0. This test is telling me I got 83 pounds of phosphorus available in soil. And what we know about phosphorus and its ability to be so highly immobile, right? I have a funny suspicion that my phosphorus uptake in the crop plants is probably very good. I would have to take a tissue sap analysis to really determine that. But because I have cover crops and I have constant roots growing and the ground is covered and I have exudates pumping into the soil, right, and your microbial network and fungal networks are releasing enzymes that are going to make phosphorus more available to the plant species or crop species. I have a funny feeling that this is most likely, I can't with confidence say 83 pounds per acre, that specifically, but I can say that I don't believe phosphorus is going to be a limiting factor for me in this particular situation, especially based on this being so much higher than the next relative suggested amount, which was, this was 45, this is 0. So I don't feel that I would need to add any phosphorus to this particular field. Potassium, similarly, this said 80. This test came back as 25. So again, there was a difference there of 55 pounds per acre. This is telling me I have 115 pounds bioavailable. So again, I mean, that's a significant amount in the soil, far greater than what is recommended by the other tests. So I feel very confident in not needing to add the potassium. So this comes down to nitrogen. And we'll look here at the nitrogen saving. So the way the Haney test, they use this kind of standard calculation based on the market price of nitrogen. They show you what a traditional evaluation would have shown, about 5.6 pounds of nitrogen available per acre, which is where they would have then recommended 58 pounds per acre. It's pretty close. I mean, this one's 70, this one's 160. So, I mean, you have a little bit of a difference there, obviously, but as we know with variability, as we know with the increase, this is 4.6% organic matter. The other test was 3.7. So that alone of what we know about nitrogen probably would have driven this number up. This test came back at 3.7% organic matter. I have a funny suspicion that this evaluation would have been, the nitrogen difference would have probably been larger, right? Nonetheless, this probably would have been lower, though, I would imagine. showing what was actually available. But nonetheless, that's how they kind of come up with this. I've listened to some people say, well, that's not accurate because the yields that they use to calculate this isn't accurate, and I'm not going to get into that. But I still think it's kind of a nice little chart that they provide to kind of show what's available. So all in all, I'm really happy with the Haney Soil Test. I will tell you that when it comes down to the nitrogen here at 64 pounds, I have used a little bit of fish hydrolysate, which is a pretty low nitrogen percentage. It's all organic. It's basically ground up fish material. I have used a little bit of that as a foliar spray in my garden, actually only one treatment, and I have had a really, really strong crop response. I will say where I believe the nitrogen is needed more so is not necessarily tomatoes, but maybe some of the peppers. I have noticed a little bit of yellow on the leaves, which could be from a few things. I mean, we've had a lot of rain here in Ohio and things. But I feel strongly that I do not need any significant amount of nitrogen in this application. Whereas if you talked to me even maybe 3 years ago, 3 years ago, I would have been taking this rate after one soil test, and I would have said, okay, I need to add all of these elements. And that would have been a significant amount of money wasted, even on a small acre scale. That would have been a significant amount of money wasted. Now, let's say that this is the same results I got back to manage the wildlife pastures that I manage, at 10 acres, 10 plus acres being planted 2 times a year. And let's say that this is the results I got back. I might just say, well, when I fill that spray tank up, I'm going to add some fish hydrolysate and just give the crops a little foliar boost. There's blood meal, there's bone meal, and I really don't have to use a whole bunch of synthetics and increase the salt load on the soil and increase the likelihood of oxidized reduction reactions, in the soil. Or I could have went to this route, which the difference here between the two times 10 acres, let's just say that's a $700 bill. Had I just gone with the first one, it would have been even more. Going to a couple foliar sprays, I mean, I might be, because I'm not really worried about making a huge impact, just giving it a slight boost. If I even go that route, I might just kind of keep it all natural for the wildlife pastures. But at 10 acres, I might be at a couple $100 if I even feel like going that route. So it's still, $500 to $600 to $700 cost savings, and that number only grows as you increase your acreage. So overall, really, really happy with the results of the Haney Soil Test. I think it does show that a lot of the variability in these tests, I believe that it shows you a really good idea of what's actually available in the soil using a mimic of a root exudate, and again, water, the two things that happen in our soil, or at least should be happening if we're keeping our soil covered, if we're retaining water through water infiltration and good soil practices, and also if we have a constant root growing, we should be exuding organic acids into the soil, which are making all of these things plants available. So hopefully you all enjoyed this video. I know I really enjoyed putting this together. It was quite a bit of work. Hopefully I didn't mess up too many of the definitions or things, but if you do have questions, I have quite a bit of notes here. Absolutely love doing this stuff, guys. So Build Better Soil on Instagram, Build Better Soil Facebook group. Obviously follow me on YouTube. Please share, subscribe. It's been a lot of fun doing this. I hope to continue to do this, and message me. Comments are always appreciated. I really enjoy this, guys. Get outside, build better soil.